The Hazard Communication Standard is now aligned with the Globally Harmonized System of Classification and Labeling of Chemicals, or GHS. This update to the Hazard Communication Standard will provide a common and coherent approach to classifying chemicals and communicating hazard information on labels and safety data sheets. In order to ensure chemical safety in the workplace, information about the identities and hazards of the chemicals must be available and understandable to workers. OSHA's Hazard Communication Standard, HCS, requires the development and dissemination of such information. Chemical manufacturers and importers are required to evaluate the hazards of the chemicals they produce or import and prepare labels and safety data sheets to convey the hazard information to their own downstream customers. All employers with hazardous chemicals in their workplaces must have labels and safety data sheets for their exposed workers and train them to handle the chemicals appropriately. Hazard classification provides specific criteria for classification of health and physical hazards, as well as classification of mixtures. Labels. Chemical manufacturers and importers will be required to provide a label that includes a harmonized signal word, pictogram, and hazard statement for each hazard class and category. Precautionary statements must also be provided. Safety data sheets. Safety data sheets will now have a specified 16-section format. Certain chemicals, due to their physical properties, exhibit physical hazards, including flammability, reactivity, and other properties. Physical hazard chemicals fall in the following classes: flammable liquids, or solids, combustible liquids, explosives, organic peroxide, oxidizers, pyrophoric materials. These are materials that may ignite spontaneously in air at temperatures above 130 degrees Fahrenheit. Health hazard chemicals are those that may cause acute or chronic health effects after exposure. It can be an obvious effect, such as immediate death from inhaling a deadly chemical. A health hazard may not necessarily cause immediate or obvious harm to you or even make you sick. In fact, you may not see, feel, or smell the danger. An acute health effect usually occurs rapidly following a brief exposure. A chronic health effect is long, continuous, and follows repeated long-term exposure. As an example of what kinds of chemicals cause health hazards, the list includes carcinogens or cancer-causing chemicals. An example could be formaldehyde or benzene. Toxic agents could include lawn or garden insecticides. Irritants may include chemicals such as ammonia or bleach. Corrosives are caustic sodas or battery acid. That's not the entire list, but it provides an idea of different types and kinds of chemicals. Containers of hazardous chemicals must be labeled in English. Generally, where there are non-English speaking personnel, the label should be in that language or languages also. Labels must contain the following information: identity of the hazardous chemical, appropriate hazard warning, name and address of the chemical manufacturer, importer, or other responsible party. You may use signs, placards, symbols, batch tickets, or printed operating procedures in place of labels on individual containers, as long as the meaning is fully understood by the people using the chemicals. There are several systems and standards for labeling chemicals, but there is not a uniformly accepted system to date. Each system and standard has advantages and limitations. The NFPA Diamond is used primarily by emergency response personnel and does not adequately signal occupational hazards. The NFPA system is good for alerting personnel and the degree of hazard of the chemical and is helpful in drawing attention to storage needs and emergency equipment requirements. HMIS, or Hazardous Material Information System, is one of the most popular systems for labeling containers. It uses standard labels to communicate hazards through the use of colors, numbers, and letters of the alphabet and symbols. The new labeling system under the GHS program will have distinctive labels and pictograms to help you identify the chemical's hazards. If you're experienced, you should know quite a bit about MSDS or Material Safety Data Sheets. MSDSs are factual information sheets that relate to chemicals. The manufacturer is required to provide the required information, and each employer is required to maintain these MSDS on file. Anyone who uses the chemical may then ask to see the MSDS to determine information that may not be provided on the labels. The employer may have all the MSDS information on an electronic database. The primary requirement is the MSDS must be readily accessible. Much of the MSDS information is used by engineers, safety managers, and others to determine the actual hazard of the chemical and develop policies and procedures for the safe use, handling, storing, and disposing of the chemical. The MSDS also provides information on what type of personal protective equipment is necessary and first aid procedures to take in case of exposure. Even if a chemical is claimed trade secret, the following minimum information is required on the MSDS. The PEL, or permissible exposure limit, and the TLV, or the threshold limit value, or other designated limits must be listed. The major difference between material safety data sheets and the new safety data sheets is the SDS, or safety data sheets, have a 16-section format. The information will be more standardized as well. The new GHS, or Global Harmonizing System, is more standardized in its labeling requirements, and the SDS and its 16-section format will add more information on each chemical. Because this is a transition from MSDS to SDS, you'll continue using the old MSDS, and you may see the new SDS from time to time. Eventually, everything will be smoothly transitioned to the new labels, classifications, and, of course, the safety data sheets. Most of the elements of the Hazard Communication Standard are retained with some updating to the new GHS.